Hello, morning, good afternoon, good night, whatever it is for you. We are going to have this online class on amphibians and later reptiles. Why is that? Because chapter 35, that is about pterostomes, is a lot. So we're not going to cover all the subchapters. We're skipping subchapter 35.3, that is about the non-vertebrate chordates. We're not studying them. And the last one on the evolution of primates. Oh, that's quite interesting, but no, no time for them. But we have to deal with these guys, amphibians. So, on amphibians, what about them? Well, we are going to check where they are located in the cladogram. That explains us what are the relationships with them. And we have different characteristics with that. That are the first vertebrate to walk on land. And they say that they are the direct descendants of the fishes. To illustrate a little bit about this, I want you to see a little video about not geo video. So, what is that? Look at this animal. Is that an amphibian? Well, it seems to be a chordate, a vertebrate, yes. But you don't see the design of the body. What's that? That is a fish, the mud skipper. I'm going to post a link to this video, so you can check it. It's quite small. But see this specific adaptation to the land. This is a fish, really, that live in muddy areas, I think on some places in Asia. But look where the eyes are, the fins that are not just to swim, they are to almost walk. And it can go out of the water and stay out of the water for a while. What is he doing? Is he just like holding his breath? He has an adaptation quite similar to the scuba divers. If you like to scuba dive, you need all your oxygen tank, your mask, and all that, so you can breathe. This guy is breathing because it swallow water and have some water here in the chambers of the gills. What an interesting adaptation. Why I am showing you this? Because this is something that I think is very similar to maybe the first amphibians. That is why it says here that they're the first vertebrate to walk on land, direct descendant of the fishes. I'm not saying that the mud skipper is our we descend from that thing or so whatever. No, I'm not saying that. I'm giving you a comparison, an illustration that is something that is going on in nature. So there are some amphibian features. Check what is typical on the amphibians. We are going to compare. Let's call our friend Kermit here. What does Kermit have that fishes don't have? You have legs, no? So you have legs instead of fins. You have an adaptation to live on land. What else do you need to live on land? lungs. Yeah, because if you live on water, you need gills. You need to extract the oxygen from the water. If you're a fish, gills. If you are mollusks, all of the other stuff that are inside the water all the time, you need gills. But gills are useless outside the water. So you need this specific organ that is quite important. What else do you need? What else do they have? They have something. They have a cutaneous respiration. They breathe through the skin. So lungs are good for them, but they are not enough. They are not really well developed. So they have that. So let's imagine that, as I said once in the exam, SpongeBob is real. Okay, let's imagine that Kermit is real and he comes to greet us, and we're going to honor him. So we are going to drag. What will happen to him? Oh, he died. Oh, yeah. But how? How is he going to die? Choking. He's going not to be able to breathe. Yeah, we will choke him today. And you have something else, another adaptation. So lungs are costly. Yeah, they cost a lot. So you need to maintain these lungs. What do you need for an organ to work well? You need to send him a lot of blood, a lot of nutrients. That is why these lungs have to have a separate pulmonary circuit. It has pulmonary veins, separate pulmonary circuit that allows higher pressure to both blood tissues. Yeah, so the blood has to reach more parts of the body, so it can work. That is another important adaptation. Then what else? If you have, um, if you need to send blood everywhere in the body, you need another thing. You need a heart. Okay, fishes have a heart. So what about the heart? The heart has to be how in comparison to the fish? Has to be bigger. Have to be a bit more complex. So the heart now is partially divided. And that improves the separation of pulmonary and systemic circuits. That is quite interesting adaptation on guys. So we are assuming the reality of evolutionary theory that amphibians came from fishes. Then, well, how so? Because we do see the fishes, so well, fishes are water and that's it. Well, remember that guy, the mud skipper that was in the video. Quite weird, isn't it? However, scientists don't say that we descend from the mud skipper. But our fishes, as I asked the question in the announcement, we have different sorts of fishes. So, main groups of fishes, we have the chondrichthyes and the ostaches. There are some other more that denotes the fishes without jaws. Oh, yeah, there is a lot. So, well, but we can classify fishes in that way. Fishes without jaws, lampreys, hagfish, and all that thing, and fishes with jaws. With fishes with jaws, we have the chondrichthyes and the ostaches. Well, there are some other ones, fishes with lungs. Yeah, there are some weird things like that. But okay, we don't have time to explore them. On chondrichthyes and ostaches, that means the sharks and the prawns and the rays, the fishes that have cartilage instead of bones. And we have the bony fish. Those are the ostaches. The bony fish, we can classify the fishes by the fins. The fins that have rays, ray, lobe fins, fish, and um, fishes that have lobes, lobe fin fish. And here in the lobe fin fish, we have the sample of the coelacanth, that is the very old living fin fish. You're going to see if we are going to check here the um, those fins of the coelacanth. We are going to see something that is quite analogous to a pelvis and a shoulder, and something that is like a leg, a potential leg on here, a potential arm. And these other two animals, B and C, are extinct. First of all, it was discovered this one, the C, Ishtostega. Scientists knew this is an amphibian, for sure. Because we know that this guy have everything that it is needed to walk on land. But it was a big gap between the amphibians and the fishes. And Darwin predicted, well, it has to be a missing link there. Something quite interesting. This specific thing that is a fish is was named Tiktaalik. Oh yeah, quite weird name because it's the local name from Greenland, I think, or Canada. This was a fish that had all these characteristics of having an arm. This is a fish that has a neck and a flat head, different than fish that have a head that is not flat. So this is basically a fish that can do push-ups. So you need to invade the land, legs, first of all, legs to support the body weight. So these sort of fish do not have legs, but if you see them, the constitution of those things, they are like potential legs. You need lungs to extract oxygen for the air. You need to redesign all the heart, all the circulatory system, so you can have more muscles. Now, to maintain all the limbs and the movement, it is going to take a lot of energy. Now, things for the fish, the things do not have too much muscles because the water helps, no? But here in the land, not really. And the reproduction has to be still in water, so it's going to prevent the egg from drying. And all the body has to have a specific system to prevent desiccation. By the way, there is another video right about this guy, the Tiktaalik, that I think is quite interesting for us to consider. And it's a bit long, okay, but this is the guy who discovered the Tiktaalik. And this is the expedition that discovered the Tiktaalik. They went to the Arctic in the Canada. So here they went to this specific place. And why they have to go there? Because they saw the map, they saw the rocks, and the rocks there, that was the specific time when it was supposed that the amphibians appeared. So they make a quite interesting prediction, and they could find them. So what is, well, this is a place that is totally barren now, but what it was supposed to be millions of years ago. Yeah, so they went out to explore and they found something quite interesting there. Huh? They found a fossil. And what sort of fossil? It's a simulation, of course. That's the name of the guy who discovered Tiktaalik, Neil Shubin. And well, he has quite interesting videos on his research, a book that's name is Your Inner Fish and some other stuff. So this is somebody who discovered something that we can call. Okay, so I will also post this video there. Let's go on. Now, what sorts of amphibians do we have around? Well, there is a lot. We have the pros and the toes that everybody likes. They're cute. I love to prank with them. But okay, those are not the only sorts of amphibians that we have. We have the salamanders and the newts that they have a different body plan than the frogs. And we have something that is very similar to an earthworm, and you can confuse this thing with an earthworm, but they are that the Sicilians. Those are amphibians that do not have legs. This guy rebelled. They said, "Come on, it's very difficult to keep legs, to keep moving like that. So let's get rid of the legs. Yeah, let's live in that way, no, without legs. Yeah, they're happy with that. So yeah, you have the anura that gives the frogs and toes, the caudata, salamanders and newts, and the apoda means no food. The Sicilians, that is the main groups of amphibians. So, well, this is the topic on amphibians. So, we're ready. You can post any question, any comment on the discussion about this. But we are going to go with the other group, reptilia. So we have here, this is the University of Florida mascot, again, alligator. I'm a gator, as you know. You are from Georgia, I think you have to be a bulldog, or you're a mammal. Okay. Well, we can discuss about that. So, okay, let's locate reptilians here in the cladogram. And I don't see them. I see amphibia here. I see mammalia here. I see aves here. No reptilia. And this is highlighted. Chelonia, Lepidosauria, Cocodrilia. Reptilians like a compact group really do not exist. It is supposed that reptilians really have very different origins and they converge here. So reptilians are polyphyletic. By the way, look for the fish. Where is the name fish here? No, Myxini, Cephalodisponot, no, Chondrichthyes, yeah, Chondrichthyes. Actinopteritis, well, those are the stages, yeah. Actina, all those things are considered fish. And fish, as well as reptilians, they are polyphyletic. They are thought to have very different origins. And that is the meaning here. So, what about the reptilians? What is typical thing? Making the differences with amphibians. So, they have key features. Those are the main key features that we need to learn. They lay eggs, yes, but the eggs are watertight, and we call them amniotic eggs. By the way, you're interested in human biology, you have heard about the amniotic fluid. Hmm? Woman that is pregnant, the, the doctor monitors the amniotic fluid. So we have something in common with these guys. The egg have something that is um, inside that protects the embryo, and we're going to see that soon. No? The amniotic egg. That is something that amphibians, fishes do not have, and that made the egg watertight. Hmm? Then the skin is different than the amphibians. The skin is dry, and it is going to cover the body, and the purpose of that is to prevent water loss. So if you're going to put a frog out there in the sun, well, it's not going to last long because all the water inside the body is going to evaporate and the frog is going to be dry. However, you do see lizards in the desert who do fine without too much water there because the skin protected from the desiccation. That's good. So it's like the cuticle implants. And something also different. It has thoracic breathing. So, well, amphibians have lungs there, but they have a different way to breathe. You see a frog that is putting here the frog like that. Yeah, the frog is breathing. That is the way to breathe. But here, these guys breathe. Huh? Thoracic breathing is a different system to breathe. And what is that more effective? Because it's going to increase the lung capacity. Lungs are going to be bigger. So that's why also reptiles could be quite bigger. And we have different orders of reptiles. We're going to see most of the orders, but what are the reptiles that are alive today? The reptiles that are alive today are the squamata, that are in the suborder Sauria. We have here the lizards. We have in squamata, we have the suborder serpentes, snakes. Rhynchocephalia, tuataras. Oh, this is a quite little sort of lizard, but it's very, very different than the common lizard. So, but we cannot, we do not have time to see all the details. We just need to remember the names here. Chelonia, that are the turtles, and well, tortoise is all these guys. Then let's move on and let's mention here the amniotic egg. So we have an egg here, and what about that? So the egg is going to have four membranes here: chorion, amnion, yolk sac, allantoids here. And this is quite similar of protecting Superman here in the spaceship, or protecting Moses in the basket. I'm trying to make a parallel here. This is the parallel that I want to make. So, stay with me here. Even for both, for Superman as a baby and baby Moses, they have the similarity on the stories that their parents were outcast and they wanted to protect the baby, so they have to send the baby somewhere. but a baby is very fragile, isn't it? Hmm? So you need to protect it. You cannot just throw the baby to the river or throw the baby to inner space. Here, baby Superman had to be protected in the spaceship. Huh? And baby Moses have to be protected from the water. It have to be covered for, in this case here, that the water can enter and kill him. Also need to have the temperature here, and I have to keep him warm. Also here the baby is not just naked here. Huh? It has to have all the protection from the the X-rays or whatever is in the upper space to reach the destination. Here is almost the same as the amniotic egg. So what is the main point of the egg? Quite similar to the seed, to protect the embryo. But here the amniotic egg of reptiles is more complicated. It have the amnion, that is a sort of like a cushion here. It has a specific the jaw sac that is going to nurture him, the allantois that is going to remove wastes, and the corium that it protects with against the uh, desiccation, and also that strange substances come there. And the shell, of course, that gives the chemical protection. So that is why these eggs are important. Now, let's other sort of groups of reptiles. We have one that is alive here, the crocodiles and the alligators, and we have all these other guys that we love them to see them hunting and killing people, mostly bad people in the movies. Stegosaur, Tyrannosaur, Pterosaur, Plesiosaur, Ichthyosaur, and different sorts. So these guys, of course, they are extinct. However, they have something in common. Well, there was a time when the earth was full of just reptiles. Well, not of just reptiles, there of mainly reptiles that were roaming around for 250 million years. And something that we have in common, that we know about them, how to classify them is because of the holes in the skull. So how we classify reptiles? By the skull. And depending on what holes you have in the skull, you're going to put them different names. So that is the criteria for the numbers of holes on the side of the skull. And if it is 0 holes, that's here on an apsid. Now you will tell me, hey, but there's a hole here. No, that doesn't count. Because that is the orbit that we also have. We don't have that hole where the eyes would be. So that is an apsid. Then we have synapses that have one hole here, and from the synapses come the therapsids and the diapsids that have these 2 holes. Now, I don't recall seeing this in the book, but why the holes? What is the purpose of having holes in the skull? That is almost nonsense, no? To having holes in the skull. Well, think about this. If you are a reptile, you are big. You need to eat a lot. If you need to eat a lot, well, and if you're a predator, you need to have a very strong brain to capture. So you need to have a strong jaw. It's not just size of your bones. You need to move that. What do you need to move bones? Muscles. And to move our jaw, you do this, you're going to feel something here on your head. Those are the muscles that are connected here, jaw, with part of your skull here. This guy have this so the muscles can go there. More muscular mass. That is what they have here. So, but there is a trade-off here. So, if you're going to make room for the muscles, there is not too much room for the brain. That's why the brain of these guys was not very big. That doesn't mean that they were stupid. No? That is a specific adaptation. So the diapsids, we have the archosaurs. Now the diapsids, the two holes. That means a lot of muscular muscle, a lot of rib. So the diapsids were replaced by the diapsids. And here the archosaurs were the first land vertebrates to be bipedal. We are bipedal. We walk in two extremities. But from then, it's supposed that gave rise to the crocodiles, pterosaurs, dinosaurs, and birds. I found this a little bit confusing, so I look online to a specific diagram that, and I think this could help. So all reptiles are supposed to came from an amphibian ancestor, and here we do have the some animals that went sideways, like the Pelicosaurus here, and the Therapsids. The Therapsids that it is supposed that they give origin to the mammals. So here they went all the way here, and it came from one side. They give rise to turtles, plesiosaurs, Nessie, the monsters of Loch Ness. That is what it's supposed to be. Ichthyosaurs was one sort of dinosaur that was quite similar um, to the dolphin. Then Tecodons, the Tuatara, that is the one guy that is alive today but was very old. Here the Tecodons, then that's the origin of pterosaurs, crocodiles here, the main dinosaurs, Ornithischia and Saurischia, and the birds. So something that people, some scientists say is, well, dinosaurs are not extinct. You want to see a dinosaur? Well, go out of your backyard. You're going to hear one. You're going to see one flying around. Those are the birds. That's another discussion. And we'll check that on birds later. And, who doesn't like that? So, wow, they are amazing. They are quite interesting. So big things that they were around. And we do see that it is quite cool to go and check them on the museums and scientists when there those big, big things that were around. So when people started to find out some of these guys, they thought, wow, those are the remains of the dragons. So we know that they dominated the Earth for 150 million years. And they became extinct 65 million years ago. And as I was talking later, we suppose that one group gave rise to the birds. How did they get extinct? The popular theory that is around, it has some proof, is that there was an asteroid impact. So how do scientists know that? Because there is a specific layer when in the here in the cortex of the Earth. When you dig around, you're going to find most of the dinosaurs under the layer of the Jurassic and the Cretacic. But here, between the Cretaceous and the Triassic, I think, there is a specific layer where there is a lot of one sort of mineral, that is the iridium. This mineral is very rare on Earth, but it's quite common on asteroids. So one scientist, and was Luis Alvarez, he made this theory of the asteroid impact at the end of the Cretaceous. Well, there were different theories around. Every scientist loved to defend his own pet theory. But finally, geologists discovered a big crater that is in southern Mexico. So we are now accepting the theory that there was a big asteroid that killed most of the dinosaurs there. And by the way, who doesn't like Jurassic Park and all the movies that came around? You have seen it. Remember the first one of the series? I'm asking you, could Jurassic Park be possible? We were talking about all the stuff that scientists now can do with DNA or so. How in Jurassic Park dinosaurs came alive? It is supposed that they found DNA from dinosaurs that were preserved on mosquitoes that were trapped on in amber. Hmm? So this was the resin. Remember when we talk about gymnosperms? The gymnosperms have a specific way of defending themselves by throwing up resin. And this resin is an oily substance that sticks to something. So if a mosquito bites a dinosaur and it got trapped in the resin solidifies and becomes amber. So it is supposed that they collected, I don't know how different blood samples from dinosaurs, and then they could clone the dinosaurs. That's science fiction, of course. However, let's think about this. Let's see if let's speculate. What about if one scientist really discovered lots of dinosaurs? So can we clone them? Jurassic Park will be possible? Let me introduce you to this lady, this paleontologist. She discovered fossilized soft tissue of dinosaurs that resembles blood. They did not find DNA, but they find something quite similar to proteins, and they are studying that. Who is this lady? This lady's name is Mary Schweitzer. It is good to know a bit about her. She studied in Montana, and she did a lot of research with this guy, Jack Homer, and a worldwide expert on dinosaurs. Something quite interesting is when she went to study with him. She said to him, "Hello, Jack. I'm Mary. I'm a young earth creationist, and I don't believe in evolution. I think you're wrong, but I would like to come into class." Jack said to her, "Hello, I'm Jack. I don't believe in God, but you're welcome. You can work with me." So they worked together. They studied the process of DNA here, picking up DNA in other living beings from dinosaurs, but they took up these samples of the dinosaur bone and they discovered something quite interesting. They discovered this soft tissue from dinosaurs that now some people said, wow, then this could be a proof of a proof that the earth now maybe is young. So something that is quite interesting is Mary Schweitzer is a Christian, is an evangelical Christian. By the way, I know her. I went to some of her talks. We talk. I invite her to Peru to go to explore the fossils there. However, she said, yeah, the discovery that she has made is that there is soft tissue in dinosaurs. And, well, nobody thought that it would be possible to find soft tissue in dinosaurs because they are supposed to just solidify. What she has found is that there is an assumption that was wrong on how fossils are formed. To use her discovery to tell, oh, now this is a proof that the earth is young, that's totally wrong. And she said that. And something, why is that for me to tell, is that even she is a Christian, she said that she loves the Lord. She go with mainstream science, said, this is what it is. That does not prove that the earth is young at all. It is not related. And most of the attacks that she has is for people that call themselves Christians. That's not a way to do good science. Okay, let's talk about modern reptiles. What about modern reptiles? Modern reptiles have internal fertilization, and that is different from external fertilization. If you were in the lab, you remember that. No? What is the difference between external and internal fertilization? External fertilization is like a fish, or like several invertebrates. The female throws the eggs somewhere, and the male comes and throws the sperm, and the eggs and the sperm unite outside body. Internal fertilization means that they make babies. How they make babies? In the same way as we make babies. We were made that way, as mammals. That means internal fertilization. They have to have intimate contact with male and female, and the sperm and the egg meet inside the body. Then you need improved circulation, so the blood is going to move, and the oxygen goes more efficiently. So that is here a difference between the fish that have just one loop. It's quite simple, quite easy. But most of the reptiles have this going on to the lungs and going to the rest of the body. So the heart is going to be different. It's going to be more complicated. A septum in heart that is going to create a partial wall to move the blood in different ways, in different systems. Now, all living reptiles are ectothermic. What is the meaning of that? That they need to get the energy from the environment, from how they are going to heat their bodies from external sources, the sun. We keep our internal temperature, but what do they have to do if they are very cold? They have to go outside and sunbathe. Yeah, that is what they have to do. And well, if it is very hot, now that's good for them because the temperature is going to rise too much. They have to regulate the temperature by moving. So when it is they are hot enough, they will have to leave their couches and go to a burrow there to protect themselves from scorching sun. So here we have the difference with endothermic animals. So if you are a mammal, you're endothermic, or a bird that are endothermic, you could be fine, even if it's freezing. But this little lizard will need an electric blanket because it's cold-blooded, endothermic or cold-blooded. So we can deduce that reptiles occur worldwide, except where? Where you don't find really reptiles. Places that are very cold, Arctic and the Antarctic. Got it. So this was the topic on reptiles. Now you can post in the discussion about reptiles or about amphibians. Yeah, add your comment, your question, your joke, or whatever. Okay, and you'll have time to post that, but check the deadline on Canvas. Okay, okay. See you there, and have a nice time.